Hello, and thank you for joining. This is an overview of the VXR Lab's chemistry presentation on chemical reactions. Now, before you start, you'll have to familiar with the following things: the structure of atoms and molecules, a basic understanding of compounds and bonding, the use of scientific tools and apparatus, basic understanding of pH, acids and bases, and basic knowledge of replacement reactions, decomposition reactions, and combination reactions. You also have to have some kind of understanding about the periodic table of elements. We're going to get you caught up though if you don't. So, know that atoms are the basic building blocks of matter, and they consist of a nucleus made up of protons. Protons are the positively charged subatomic particles that make up the nucleus of the atom. Neutrons are actually neutral. This means that the nucleus itself is positive. Then you have an electron cloud. Electrons are the negatively charged particles that live in energy levels or what we call orbitals. Now, molecules are formed when two or more atoms actually bond together. These bonds can be covalent, which means that electrons are being shared, or they could be ionic, which means that electrons are being transferred from one atom to the other. And it depends on the type of atoms involved. Covalent bonds typically involve nonmetals, whereas ionic bonds are a metal and then a nonmetal. Compounds are substances that are formed when two or more different elements actually chemically combine in a fixed ratio, like H2O. They can either be molecular compounds, which are formed by covalent bonds, again, like H2O, or ionic compounds that are formed by ionic bonds, like salts or NaCl. Covalent bonds happen when two atoms actually share electrons. That means that the outer shell has a full valence or contains 8 electrons. This happens between nonmetals. Ionic bonds actually occur when there's a transfer of electrons from one atom to the next. So if you have a cation and an anion, that means a positively charged ion or a negatively charged ion. One actually loses electrons, that would be the positively charged one. And then the nonmetal gains electrons, that would be the anion. So, for example, in sodium chloride, sodium donates their electron to chlorine, which forms sodium positive and chlorine negative ions. pH is a measure of how acidic or basic or alkaline a solution actually is. The range is from 0 to 14. pH 7 is neutral, like pure water is. And if it's less than 7, then that means that it's an acidic solution, which means that it contains a higher concentration of hydrogen atoms, or H plus, which is a cation. pH greater than 7 indicates a basic or alkaline solution with a higher concentration of hydroxide ions, or OH minus. There are several different types of reactions. A displacement reaction or replacement reaction happens when one element replaces another element in a compound. And there are two different types. You have single and double replacement reactions. In a single replacement reaction, one element replaces another in a compound. So you'll have A plus BC, and then it kind of switches away around. It's almost as if a single person goes out on a double date and leaves with another partner. Then you have a double replacement reaction where two compounds exchange elements to form two new compounds. So it's like going on a double date and you both leave with different partners. So A plus B, A and B plus C and D go out together, and then A and D and C and B leave together. Decomposition reactions are when a single compound actually breaks down into two or more simpler substances. Usually it takes energy, something like heat, light, or even electricity. So you have something like A and B, something that is a compound that is formed that actually breaks up into two different components, or the components that made it up, A plus B. So the decomposition of water into hydrogen and oxygen would be an example of a decomposition reaction. A combination reaction is also known as a synthesis reaction. That's where two or more simple substances actually combine to form a more complex compound. So typically that's like A and B getting together and forming one molecule, A and B. So the formation of water from hydrogen and oxygen would be an example of a combination reaction. Now, combination reactions and decomposition reactions are just the opposite of one another. You also need to be able to identify the characteristics of a chemical reaction. You also assess the impact that pH and temperature have on chemical reactions, and you will demonstrate the safe use of dangerous equipment and chemicals. You'll be doing all of this in virtual reality. So here are your tasks. You will gain familiarity with a wide variety of chemical reactions. You will recognize the role of heat in chemical reactions. You will recognize the role of pH in chemical reactions. You will learn about transfer of atoms between molecules, and you will recognize that not all substances have the same chemical properties. Inside of your virtual reality headsets and in the experience on chemical reactions, you will have this VXR fabricator. Now, the fabricator is where you can go and replace any necessary lab materials at the press of a button. The only equipped It's only equipped with the materials you'll need for a given experiment. So, if you need a beaker and that's all you need, and you don't need a test tube, it won't create you a test tube because you don't need it. On table one, you'll have your different toolkits. You have 5 different tables that contain all the materials you'll need for the experiment. So table 1, 2, 3, 4, and 5, everyone will start at a different table, and these are the materials that you will have. Make sure that you have paper, notebook, and a pencil, and a recorder as one of you. So you will work in pairs. One person will be the recorder in the first half of our session, and another person will be the person that is in the headset actually showing and doing the experimentation. You don't always have to remove your headset to interact with the world around you. You can actually use pass through on your headset to record your analysis. So it doesn't mean that one person can be in the headset while the other one isn't. You can also use pass through, and I'll show you how that works. The first experiment is a combination reaction. You'll place a strip of magnesium onto a watch glass. You'll place that watch glass onto a ring over the Bunsen burner. You'll turn the knob on the Bunsen burner to light it and adjust the flame size, and watch the chemical reaction occur as magnesium reacts with oxygen. Now, you'll repeat steps 1 through 4, and you'll use sulfur the next time. The second experiment is a copper content analysis. You'll obtain a penny and weigh its mass on the scale. You'll place this penny in a beaker and use a transfer pipette and cover it with hydrochloric acid. You'll leave that penny in the beaker until the bubbling stops. That means the reaction has stopped. You'll turn the beaker over and discard the actual acid. Then you'll weigh or take the mass of the penny one more time. The zinc inside the penny would have reacted with the hydrochloric acid, but the copper on the outside will not. The new mass actually represents the amount of copper that is left in the penny. The next reaction you'll do is a single replacement reaction. You'll place a coil of copper wire into a beaker. Using a transfer pipette, you'll take 25 milliliters of silver nitrate and you'll add that to the beaker. Now, the reaction that occurs as copper displaces the silver will have crystals that actually form. So you'll use another transfer pipette and add 3 drops of hydrochloric acid to a test tube. You'll drop a magnesium strip into that test tube, and you'll watch as the strip dissolves and bubbles form. Using a transfer pipette, you'll add 3 drops of water to a different test tube. So these are 3 different reactions. You'll drop a single piece of calcium into that test tube and you'll watch as hydrogen bubbles form on the calcium chunk and starts to float. So you'll be doing 3 different single replacement reactions. Then the fourth experiment you'll do is a decomposition reaction. You'll use copper 3 sulfate and you'll put it into a test tube. You'll turn the knob on the Bunsen burner to actually start it. Using the test tube clamp, hold that test tube of copper over the flame. You'll watch as the color changes and water evaporates. Now you have an anhydrous copper sulfate that is actually formed. You're going to repeat the same procedure, but this time you're going to use ammonium carbonate. You'll watch as the flame changes and a gas is formed. You'll place litmus paper over the mouth of the test tube to determine the pH of the gas that is actually released from this decomposition reaction. The fifth experiment is also a double replacement reaction, and there are multiple combinations that can be done. You can use any one of the nitrates and mix it with either ammonium carbonate or a sodium phosphate. You'll use a transfer pipette and you'll add, say, 8 drops of the silver nitrate to a test tube. You can use a pipette and you'll add the drops of ammonium then carbonate to the same test tube. Now, silver nitrate plus ammonium carbonate will form silver carbonate plus ammonium nitrate at the end. You'll stir the mixture with the stirring rod and observe the reaction. A solid or precipitate should form. You can repeat these steps with silver nitrate plus sodium phosphate, copper nitrate plus ammonium carbonate, copper nitrate plus sodium phosphate, aluminum nitrate plus ammonium carbonate, and aluminum nitrate plus ammonium carbonate. In a double replacement reaction, remember you start with 2 substances like silver nitrate plus sodium phosphate, and you'll leave with silver phosphate and sodium nitrate. The sixth experiment you're going to do is a neutralization reaction, and that happens between the acid and a base. You'll use a pipette and transfer 6 drops of phosphoric acid into a test tube, and it's going to be colorless. Using another pipette, you'll add 1 drop of phenolphthalein indicated to the same test tube. You'll then add 3 drops of sodium hydroxide into the same test tube and stir that mixture with a stirring rod. You will notice a color change that is caused by the indicator, which is phenolphthalein, as sodium hydroxide actually neutralizes the acid. Now, you'll repeat this procedure using sulfuric acid the first time and then add nitric acid the second time instead of the phosphoric acid. Notice the color change with each particular trial. Now, you will answer the following question. Were the reactions in experiment 6 chemical reactions or physical changes? You'll also justify your answers based on your observations. Now, you will draw certain conclusions about these chemical reactions, and after each one, you're going to think about what evidence did you observe for chemical reactions in each of the experiments, whether it was color change, precipitation, or a solid forming, or a gas actually forming. And in which of these experiments did you observe the formation of a precipitate? What does this tell you about the solubility of the products? And then how did the reactivity of copper differ when reacting with copper nitrate, silver nitrate, or aluminum nitrate? And then what do you think of ammonium carbonate and sodium phosphate in these reactions? How did the reagents influence the actual products that were formed? These are some of the conclusions. I'm not going to let you look at them now, but you should do at least one of these. Be able to balance a molecular equation, and we can work through them together when they form, or discuss the potential molecular interactions that may have happened from a precipitation form being formed. At this point, you would have completed the chemical reactions VXR lab experience. You will flip your wristwatch inside of VR and exit the experience and go back to the VXR lobby. When you do this, your activity log for this module will be sent directly back to me. Thank you so much, and make sure that you exit back to the lobby so that your results from this simulation will populate for me to be able to look at. Thank you so much.